In order to simplify algebraic expressions easily, we need to be familiar with our index laws. And index laws, are the rules around how indices, that is powers, behave when we're multiplying and adding and raising them to each other. So index always refers to the power, the little number up the top above prime numerals. And there are some rules about how they behave. Now, these rules aren't just made up by mathematicians because they felt like it. These rules exist for very good reasons, and it's because of the way that multiplication and addition work. Now, in class, your teacher will hopefully have showed you how to use these index laws. What I'd like to do in these videos is kind of show you where they come from. So the first index law we're going to look at is a to the m times a to the n. And if we've got an expression like this, the result is a to the m plus n. Now, sometimes students can find it confusing because there's all these pronumerals floating around. The important thing to note, the a's are the same. The base, or this bottom number, is the same. If that's the case and you've got two things multiplied together and their powers are different, you can combine them into a single term with that base, same base as before, and add the powers together. So an example of where this would be happening, if I had 2 to the power of, actually I won't even go with 2, I'll go with x to the power of 3 times x to the power of 4. I could add those two powers and I'd end up with x to the power of 7. If I had t to the power of 8 times t, this is the same rule. Even though I haven't got a power written here, it's understood that it's t to the power of 1. So the result here would be t to the power of 8 plus 1 is 9. You can even do it with fractional powers. Use t. Let's use p. The power of 3 times p to the power of a half. This would be p to the power of 3.5. We don't like having mixed numerals like this, so we'd normally change it into 7 on 2. Or even if they were negative, we can have that as well. 5 q to the 5 times q to the negative 2. 5 plus negative 2. Well, that's the same as 5 take away 2, q cubed. All right. Question I really want to ask today, though, is where does this rule come from? Why does this happen? And it happens because of what this power means. If I write, for example, a squared times a cubed, let's think about what each of these means. A squared, well, that just means a times a. And a cubed, excuse me, a cubed means a times a times a. So what we've done is we've expanded out the power notation like this. Okay, so these three a's correspond to that term. These two a's correspond to that term. And let's have a look here. I've just got 1, 2, 3, 4, 5 a's all multiplied together. Well, that's the same as a to the power of 5. And if we have a look here, we've got 2 plus 3, well, that's equal to 5. So by expanding it out like this, okay, we can sort of see where this rule comes from. Of course, the power of the rule means that we don't have to write this out every time. If I gave you a to the 50 times a to the 42, you don't have to write out 50 a's and then another 42 a's going off the page. All we have to do is go, well, if I wrote them all out, there would be 50 plus 42, that's 92 a's. So this is going to be the same as a to the power of 92, even though I didn't have to write it all out. So that's the first index law when we've got two things multiplied together.